All right, good evening. It's like 15 past noon. All right, good afternoon, everybody. It is, let me check the date. It is Tuesday, June 24th. I am on our Helios G4 PFIB CXE, and I'm in the process of lifting out some lamellas, and I wanted to share with you guys and girls a new technique I've been using for attaching lamellas to a grid. Okay, so this is something I've been doing for a while now, and I find that this works much better than the approach that I had been using, which was to basically, because I like to mount in the notch. I don't like to mount like on the side of the post, like flag mounting. I don't like to do that. I like to mount in the notch. What I historically would do was I would basically weld at the two bottom corners of the lamella to the grid, and I'm going to show you an alternative method that is more secure in terms of holding the lamella, okay? Because I've actually seen this, unfortunately give me some issues where, the lamellas, they disappear, they get lost, or there's problems, okay? So, and you don't want that after you go through all the hassle of making the lamella. So we're going to go over this new method I have, and it's really not very complicated, but it's something I really haven't seen very often, so I thought I would share it with everyone. So anyways, again, I've said this before with the PFIB videos, the screens don't normally, the quads don't normally look like this. They're like this because of the way the screen capture works, so keep that in mind. But let me go ahead, I'll unpause. So I'm already over the post that I'm going to attach the lamella to, and you can see, so I've already prepped this, and if you watch my video about prepping molybdenum grids, I'll put a link to that so you see how I do it. But basically I have removed the front half of the post here, and then I've leveled off the top of the post so that this is now tapered, and this part here is the highest part, and this is the lowest part, and the lamella is going to go right here, and this ensures that there is nothing blocking the lamella. Okay, as one of my trainees said, her name is Sadie, she said it's like you're on the top of a mountain. So, and I'm going to use that and give her credit for it. You can see here that I'm looking basically edge on, so I don't really need to make an adjustment with the tilt. Again, let's say I was, right now that's not edge on, okay, so pretend I'm at 0. Well, then you need to change this until you get this to be edge on. So in this case, I already know it's at 0, and so there you go, right? You can usually dial this into within like half an increment. So if we actually go minus 0.5, you can see that's noticeably off. I do believe that there is a limit to how negative you can make the tilt and still insert your easy lift. So please keep that in mind. Maybe we could pitch this forward. Okay, so maybe we could do 1/4 of a degree. Okay, that's actually a little bit better, so we'll leave that there. All right, so then is the grid straight from left to right? We can find our align tool in the toolbar. Left click and drag, so this can be tweaked just a little bit here. And we want to align to horizontal. And that looks better. All right, so now I have my ion current at a low value here, so I'm going to go ahead and unpause that. And so now I'm going to use my stage Z to bring that down to the middle. And I'm going to go ahead, I forgot to relink there, but that looks okay. I'm going to boost my SEM current here a little bit. It's going to make monitoring a little bit easier later. Okay, that looks decent. I'm not going to be meticulous about, aligning that for the time being. All right, so now at this point, link the working distance. We're at eccentric basically, and we can go ahead now, insert our easy lift into the park position. We can insert our platinum as well. I resisted the urge to start chewing some gum because apparently, somebody complained about that. So, I don't want people to complain about my videos, so, I'll do my best to not chew gum, although I will admit I have a gum chewing problem. I go through about half a pack a day, but hey, that's better than going through half a pack of cigarettes a day. Okay, so here's our lamella right here on the easy lift, and we need to approach it down to the post here. So this is more than 200 micrometers away, so what you can do if you're feeling adventurous is you can do the step and do down 100, and then I don't recommend you do another one because if you're off with this, you could easily smack into the post. So I recommend you just do steps of 10, and you do this just incrementally. You should start to see it here soon. I think even doing the calculation, I would have been safe doing 2 100s, but I just didn't want to risk it. Okay, and I'm going to switch to jog mode and just go 1 micron a second. Okay, and that's good as far as the position. It doesn't have to be perfectly at the edge, but that's perfectly fine. Okay, and then what I'm going to do with this is, because we're on the PFIB, the deposition is more effective at 12 kilovolts, so I'm going to drop my voltage on the PFIB down to 12, and I'm going to increase my current to 0.33 for this approach that I'm going to use here. Okay, you can go ahead and focus and stigmate. Okay, looks reasonable. I'm using shift and then left click and drag to center. Okay, and now I'm going to turn on my flow. Let me go back to the SEM and see where this is at. That looks reasonable. I'm going to go up just slightly. Yeah, it's backsliding a little bit. I'll just leave it there. That's fine. Okay, so now I'm going to approach this down. Okay, that's close enough. And now take a snapshot. And here's the new approach. So instead of welding just the corners, I'm going to use a big old rectangle here. And this is why I used the higher beam current, because you have a larger pattern, so you can get away with a higher beam current because you're targeting the appropriate current density, right? So if we have 20, so I have about half onto the lamella and half on the bottom of the grid, okay? So we'll do the calculation here while this is going, but I'm going to go ahead and start this. And so by welding the whole bottom here, you really secure this really well to the post, okay? So you're not going to have to worry about, except in the event of something like blunt force trauma, losing the sample. So while this is happening, let me pull up the calculator here so we can calculate. So this is 22 by 3.5, and we have about 420 picoamps of current. So we have 420 picoamps of current divided by 22 divided by 3.5. Yes, so a current density is about 5.5 picoamps per square micrometer, which is right where we want it in terms of the optimal number. Okay, and so you can see this depositing here on the SEM, right? So it's going over that exposed lip right there. And so as far as the accumulated depth, maybe 0.25, 0.3 micrometers accumulated. You can unpause this and see as well. You can turn down the contrast. Yeah, it's pretty blurry there, but we're getting the deposition here. That's what matters. But this is how I weld all my lamellas now. Okay, I use a rectangle and I weld the entire bottom of the lamella to the post. I no longer just weld the corners because this is just far more secure. Now, of course, when you do the final thinning, you are going to end up cutting through part of the middle there, but I still find that this is more secure than if you just did a corner or the two corners individually, okay? And it's certainly more secure between now and when you actually do the final thinning, right? Because the last thing you want is to lose the lamella before you even get to the final thinning. Obviously, there's no need to change the voltage if you're on a gallium FIB. Okay, I only did that because I'm on the PFIB, but on the gallium tool, completely unnecessary. You can stay at 30 kilovolts. All right, so I'm going to stop this. Well, I'll stop it at 0.35. That should be enough. Okay, and so now I'm going to put my current back to 30, or voltage back to 30. My current to 1 nanoamp. Change my material back to silicon. Okay, you want to be very careful about clicking and dragging inside of here that you actually are activating beam shift and not the stage, because otherwise you will bust your weld there and you'll be pretty angry if you do that. I haven't done that myself. I came close once, but thankfully it didn't happen. All right, so now as far as releasing it, we're just going to use a nice slender rectangle here. And we're going to cut right through there. But you can see, right, I got a nice deposition of platinum there. So this lamella is nice and secure and is going nowhere. See, I've been meaning to do a video showing this because I've been doing this for a while now, and finally had a chance to do that. So. All right, oops, all right, I didn't make the Z depth enough here. We'll just overkill it, make it 10. Something that I've seen happen, so we got a new dual beam system, which there'll be videos about eventually, but what we saw was this interesting issue where when the GIS is inserted, even after the flow is closed, that we're getting a lot of filling in of where we're milling. Even after the GIS is closed. So what we determined was that the GIS was actually leaking. So if you're seeing a lot of redeposition after you do like a weld to your easy lift, and you're wondering, and you're trying to cut your lamella free, and you still have your GIS inserted, that's probably what's going on, is you have a leaky GIS. So that's a malfunctioning GIS unit, and that should be addressed by your service contract if you have one. Okay, so looks like we got clearance. Come over there. Move that out of the way. It jittered like that. Okay. Go to park. Okay, retract. I'm going to put this back to maybe 10 picoamps, and we'll take a look at this a little bit more accurately here. Yeah, so you can see very clearly here I got a nice thick weld here of the PT, and that's going to be nice and secure. Okay? All right, so that's the quick hitter video on an alternative approach for welding lamellas to your OmniProbe grids. So happy Tuesday, everybody, and hope all is going well for you. Take care.